Okay, so this presentation, I'm going to try to be quick and straight to the point. This is about patterns. In the same way that you have patterns on, I don't know, coding or UI patterns, you also have patterns for automated testing. This ties down a little bit to Louis' presentation because these patterns that I'll present are kind of supporting us along the way. This we've been testing this for a while, even other projects, other companies. So this is not something you read in a book and try to sell. This is more like after our experience, what is working out for us. All right. So the first thing is this is not a pattern, just a starter sentence that I like is that the same guy that wrote TDD and everything had a huge influence. Uh, Kind of hints that we should be economical on tests. So we have to write tests in a way that not for the sake of themselves, not for the sake of coverage, not for the sake of, just for the sake of something. And that something is your testing strategy, is your the automated testing goals. So you have to talk about it. What are your values at the company, at the team, as a person? What are your values? And then from there, you will derive your strategy to write tests. It's not just writing tests, oh, because we have to have 80% coverage. So before going to the pattern themselves, this is just like a priming a few slides. What are the goals of automated testing in the first place? Why do you write tests? Why do you have automated tests? And why do you put them in between you and deployment? People think that this is the most important one. I think everyone agrees on this. The safety net is the biggest reason for writing tests, so that will influence the patterns, surely. The thing is that there are more than that. There are more goals than that. I identified like 6, but there are even more. So, and these goals have to shape your decisions. Like, I like this sentence, by the way. Uh, you were fast without tests until the next leg of your journey, just like parachutes. Um, so another goal of test is a design tool. So here, obviously, I'm going to talk about TDD because it shapes the how you'd like your implementation to be, not only not only API wise. So what is the expected way to talk to the implementation? Because tests are the first customer of the implementation, but also it also hints on design, like in terms of architecture. It's also hinting the tests have the power to hint you on certain directions. So yeah, it works in multiple ways at the same time. Also, as specification, so ultimately you could delete you could delete the implementation and start over depending on the quality of your tests. Of course, you're not going to do that, but this is just to say that this is also a goal of automated testing or testing. That's why sometimes they even call it specs in some languages, and in our spec they call it like that. But finally, well, not finally, but the ones I identified here, and I think this is the most overlooked one. Tests are documentation. For example, when you go into a new code base, I look at the tests first, or I hope they're good enough to understand what the code is about. What does this project do? Tests should tell you that. If they don't, they're not doing one of the most important goals. And again, this will have a huge impact on the testing patterns that I'll present. So if you want the library, you go to automated tests, the same as a new code base that you have at work. Uh, this is the one of the most important books in the XUnit world, JUnit, etc. They had a huge influence on testing in general. And again, it's putting more importance on the tests as documentation. For example, when you have a bug, you're going to try to simulate it with test, and that on its own is a test. Is a little bit of documentation. Yeah, so I think I passed this point. Again, this would be its own presentation, which I don't, which is not the goal today. Just to call your attention that test is not about coverage. Test is not even just about safety net. Test is all this and more. So it can be a bit daunting to, when you write a test, how to write. You have to have all this in mind and more. It helps if you talk with the team about it, what is the strategy that we should follow, but it also helps if you know a little bit, a few patterns. Okay, there we go. It's 7, so I hope I can cover them all. Tell me if I'm going too fast. First one is one action per test. So this is also known as the anti-pattern version of this is known as the free ride or piggyback, because you do this and then, oh, since I'm already in this state, I'm going to also do that and that, a little bit of assertions, and then you have a lot of code. And this is not helping the reader, because what is the thing being tested here? Many things being tested, many things being asserted. So first thing that you have to do when you go into a new code base and this is not good, try to copy paste the test and try to identify where one action starts and another action starts. So yeah, this is the bad pattern. This is a good pattern. You interact once with a SUT, by the way, means test subject. Sorry, system under test, which is the same as test subject, is whatever thing is being tested at the moment, regardless if it's a low level or high level unit test. You always have a test subject. This is an example code-wise. I think this is C sharp. You're calling the same thing twice, so you might as well have two tests so that the reader can focus on, okay, these conditions lead to this conclusion, and this condition leads to that conclusion. Test as documentation. This has a lot of weight here. The fix to that, okay, two tests. Great. That's as easy as it is. Now, maybe it's not that easy, because this one is like a pure function, has no side effects, has no state, so it's just split, right? Sometimes you might need to do some setup before to leave the SUT, the test subject, under certain conditions, under a certain state that you'd like to test your condition at. That's fine. You can call the SUT multiple times. I kind of lied before saying you can only interact once. That's not true. You can interact more times, but the focus, it's still only on one operation and no more. You can call it to prepare, you can call it to assert. That's fine, but the focus is on one single action. By the way, this is just a detour. This is a good example of a table driven. Consider it, but very carefully, because I think people abuse this. Like, oh, I can put a lot of tests in the same test. That's great. Then we've seen in checkout that you have a huge array of every possibility in every outcome, and then we have one test that runs them all. This is the nightmare of testing, so don't do that. Table-driven testing here would apply nicely in this example, because you have a slight variation in the input and a slight variation in the output, so don't make me read 30 lines just to understand. The only difference is the little input and a little output. Okay, use table-driven, that's fine. Another way to view this, we'll go on to that later, but this is another way to look at the issue, at this pattern. Just act once, even though you might arrange and assert through the SUT, you are only acting once, and that's why the call to the SUT or the test subject, I don't know which one is better, should be one call. Ideally one line, but of course sometimes you need multiple arguments. That's fine, but it's just one code expression per se, let's say. So isolate it, make it obvious. Maybe even make the test files should float around that action. So organize your tests by that. So please don't create integration test.py, for example. That means nothing to me. Doesn't tell me anything about what your code is doing, what your deployable is able to do. Make your test names float around use cases. In this case, they are the actions. So that's how you should name your tests and divide them. Okay, great. Another second pattern, one effect per test. Now, effect, or there's many words for the same thing. Effect, side effect, consequence, behavior. That's also a word I saw. Many words, but regardless, if one action can lead to A, B, and C, then you're going to split again into 3 tests. Like, imagine if the example I showed before, the same calculate discount led, I don't know, sending an email, for example, you would have 2 tests. Don't assert in a single place, every single operation. This is kind of inspired by one thing in our spec. One pattern they have is do an assertion per test. I think that's a bit extreme. Well, a lot of extreme, but make sure you assert a concept or a behavior. Like you can assert it's 200 and the response. It's the same. It's very related, but don't assert 200 and I don't know, sending an event. That's nothing to relate to it. So if you want to fix an issue on sending an event, you go directly to that test. You don't have to try to find the assertions related with that consequence. Yeah, one reason why I said one behavior per test as an alternative name is that tests are about behaviors. Unit tests, regardless of their size, are about behaviors, not about calling functions and seeing the mocks result on the mocks. Unit testing should be more about observable behaviors. Yeah, asserting one consequence. That means on the assertion side, you would be not doing one assert. That's asking too much, but asserting one one behavior. So the a bad example, asserting three unrelated things. Good example, split this guy into three. Okay, third one, and I kind of already hinted about it, but I wanted to leave it for later. Now that we already imagine you have a huge test doing many effects, many actions. Now that you'll probably split this guy by many tests, that's fine. Uh, you end up with a test doing one thing and asserting one thing, and now you can promote this pattern, which I think it's very simple. It's very doesn't it's not asking much, but it has a lot of power. So a lot of power for a very simple thing, which is make sure you only have three blocks in your test, just two new lines, because in a milliseconds, in a few milliseconds, I can immediately identify the three phases of a test. And again, I'm promoting the previous patterns that I mentioned. If I force my tests to be three blocks, if I cannot make three blocks, probably I could split that test. Maybe it depends. This is just alternative names for the same thing: arrange, act, assert, given, when, then, setup, exercise, verify. This is just a reference to Newton's third law for action. For every action, there's a reaction. This is how you should look at act and assertion or behavior. So a more code example. So just to tell you that this is not something I saw in the book. This is something we are actively using in multiple projects and even other companies. This is working very well for us. So here you have clearly a preparation phase of these mocks, whatever they are. This guy is even creating something on the database underneath. And this is the act. You can clearly look at this. You don't even need to read the test title. You know you are creating an adjustment, and with this input data, you get this outcome, you get this behavior. That's You almost don't need to read the test titles. This is in Go, slightly more verbose, but still you can identify three blocks and one action and one consequence. So let's not go into detail, but this is just to show you the power, the visual power of this pattern. This is more like an aesthetic pattern, and I'm always that guy in the team. Can we please divide in three? Yeah, but I hope I'm understood. So yeah, regarding test titles, I don't like to put a lot of value on test titles because again, I like to make the test so clear that I don't need to read them. But we found a strategy for naming that works for us. We try to summarize in a sentence uh, the act and the assert. So remember the three parts. We don't need to say the assert, the preparation part, the arrange, but just the act and assert in a sentence. So adding an item returns an error when the cart has, sorry, adding an item on a cart that has payments returns an error. So act, assert. Adding an item updates grand total. So this is all the same act, different consequences. So we try to summarize it in such a way, separating by underscore. But again, this is I don't want to put a lot of importance here on the test naming. Okay, another one, assert with the test subject. So look here below. You have at least me. I take a while to understand this code because it's very coupled to low-level things. In this case, database, and it takes a little time to understand what is asserting. Not to talk about the coupling to details and how you have to repeat this all over. So why don't we just use the actual subject under test to test the thing? So yeah, I like this tweet because yeah, the database is not an API, so not the schema is not an API, so don't use it as such in the tests. Not to talk, you if you use it to arrange. By the way, in this case, you might even be skipping business rules that wouldn't even allow you to reach such a state. So there's so many reasons not to use the database directly in tests. This is just a few of them. So Yeah, you can see on the top an example which is not as high level, because this I put this one here, but this one is more like HTTP entry points. So focus on the top first, which is simpler. You are using the test subject to assert. So here you are asserting. Yeah, maybe this is not a good example because this returns the thing. I think I made a little mistake here, but this one below I think is a bit better. So you are creating two users, you delete one, and then you are using your own system uh, to assert that is your expectation. There's no coupling to details, and you are indirectly testing list users. Maybe you don't need the test for list users. Maybe you do, but probably you don't, because list users is indirectly tested through this assert block. Uh, oh, yeah, okay. This is the one I wanted to show, but sorry for the UI glitch. So you withdraw, you do this action, but you're using, yeah, you get the point. I think this is just to get the balance. So you're using your own as test subject to get the remaining balance. You don't go underneath to whatever you have underneath to your test dependencies. You use the test subject. That's a powerful pattern for us as well. Uh, as a side note, beware of testing more that in the assert block. Beware of testing more that you need. Just focus on one very specific condition. Uh, yeah, I think I covered this advantages. So you don't change your implementation code like, oh, I have this command that does this, but it doesn't return anything. Oh, I'm just putting a return for the sake of testing. So please don't do that, because you're creating code just for the sake of testing that doesn't run in real life. Or you're creating an alternate method just to go look into the uh, test subject. Also, you're creating code just for the sake of testing. It's not good. Increased safety net, because again, you're using the assertion block to run your SUT. So you are testing much more combinations indirectly. Uh, yeah, you document, yeah, test as documentation. You don't in readability, because you don't deal with low level concerns. You just read as an English sentence, as a recipe. And I covered this one. You don't create impossible states, because you always go through your business code no matter what. When I say business code, it really doesn't matter how big the system under test is. It can be like just a class or a huge system. It's still gonna have to have a way to observe it. I'm not seeing the chat, so please tell me what's written
Yeah,
there.
it's me. It's me. So in the case of checkout, the system under test for a lot of the tests that we've been writing is the whole service, is the whole checkout service,
Yeah.
and we interact with the service as a whole. So we create a cart with the services APIs, we fetch the cart with the services APIs, and we change the cart with the services APIs. And because we have this DSL, it's much more readable for one, and it's much more reliable because we know that what we are testing is exactly what, or more or less exactly what the
Mm.
user experiences.
Yeah.
There are a few concerns in terms of, okay, the internals, how can we test internals? Well, we don't test a lot of the internals directly because we know that we have to do these huge refactors and huge re-architectures of the service. So writing tests that are low level would actually hurt us because they would be breaking all the time. We need to confidently re-architect the whole service, and that's why we have these high level tests.
Yeah. So supporting refactor was actually one of the testing goals that we saw in the beginning. You have to write tests that support you when refactoring, not tests that are a burden when refactoring. So you don't want to be like an employee of tests. It's the other way around. They work for you. Who wrote, and did anyone wrote any question, or can I go on? I heard a bit.
Just quick one.
Yeah.
And at whole checkout, then you use the Postgres database, or there is some in-memory
Yes.
store.
Yes.
Postgres. And you
Yeah.
do cleanup after test.
Yes.
Every test.
After each test.
Yeah.
Yeah.
You might be worried, oh, isn't that slow? But we run dozens or working toward hundreds of tests in a few seconds, like less than a minute or less than 30 seconds. So even if it could be faster in other ways, we're happy to pay the price, because the name of those tests is sleep well at night tests. Another way to call this discussion is the well-known state testing versus interaction testing. So in the interaction testing, you're testing mocks, you're not testing the system. So generally, we prefer state testing. I'm reading this book, so that's why I have a few quotes from there. In Google, they also prefer this testing, and they give you a bunch of reasons for that, which are more or less the ones I gave you. You might say, oh, but there are side effects that I cannot observe from outside. But then I would ask, why are you doing it in the first place? If you cannot observe it from outside, then don't even implement it, or don't test it, don't implement it. So that's the point of it has to be observed. Anything can be observed by the user of the system. Otherwise, you shouldn't even be doing it. If it cannot be observed, then what's the point of doing it?
Caches.
Caches.
And
Okay,
this is
that's a good example.
optimization, and that's like the hard part.
Okay,
Sorry,
but
go ahead.
that's a good. No. That's a great example because this technique shouldn't be used like religiously. It should only be used by default. The default should be this, and then when you have these specific behaviors, that's fine. You create a lower level test, and you use whatever other techniques you have. Maybe interaction testing would be fine. That's okay. But the default shouldn't be that. I think these are exceptions that prove the rule. Uh, I think I'm over time, so tell me if I should continue next week or
You're not over time. You have
no.
20, 25 more minutes, I think.
Ah,
To add to the caching thing, there has to be a reason why you're adding cache, right? And there has to be a user experience motivation for adding cache, or maybe it's an economy thing,
mm,
a money thing for the service. In either way, this is testable from without you needing to, I don't know, mock the whole caching mechanism. It's testable from the outside. A cached response is faster, for example. So you can test that a cached response is always faster than the original response. You can test that the data is actually cached, for example. And especially if you're doing dependency injection, you can inject some kind of mock or spy to see how many times certain things are called, for example, a client library. Without you even testing the caching, you can see, okay, this client library is called once or it's called 100 times. Right? This
yeah, but
is,
that's interaction testing. That's when we fall back from state to interaction. But still, it's a good example, I think.
yeah. But there are multiple ways without, testing whether the cache actually has stuff, because the cache really doesn't matter how it's built so long as it works, right?
Yeah. So this one is barely the same as the one before, but the only difference is that rather than applying to the assertion phase, I'm trying to sell you the same thing, but for the arrange phase. So use your own system. It's like dog fooding kind of. You're using your own system to test your system. In this case, to arrange your system, and indirectly you're testing. In this case, you're indirectly testing create user. Uh, so the advantage is barely the same as the previous pattern. Um, by the way, you may need some sanity checks in the assert phase. So I could put some, for example, I could save the response from create user and assert that it was 201, I think. I could assert because there's no point in deleting a user if the user wasn't created. So I could have an early fail. It could be odd to see an assertion in the preparation phase, but it's only to make sure I set up the thing as I expect. So it's not like I'm mixing two tests into one. It's only the whole goal is to test delete user, so I might as well fail early if I'm using the test subject to prepare itself. Um, so yeah, this is kind of a summary of what we've seen so far. Arrange from this is kind of arrangement is great because you're using the system itself, and you act on it once and you assert on it directly looking at it. So don't go avoid mocks, avoid writing into the database directly, avoid reading from the database, avoid spies and mocks and such. uh, Avoid doesn't mean don't use, but we don't even use the mocking library lately. um, Everything is by default observable and actionable on the test subject, regardless of the SUT size. Um, Yeah, this is just a side detour, just a little detour. Make the range complete, local, and concise. This means that complete means that it has all you can see all it matters in the range phase. You are not magically inserting things in other methods. Don't create those setup test or before all, before each. We can use them, but more for database startup, for example, database cleanup, that's fine, but not to do stuff that matters for the test. Even if it's in the same file, don't make me scroll up and down just to understand where this value came from. I want to read all it matters in this test and without having to navigate the code. Code tests should be declarative and evident and self-explanatory. And concise, it's the other way around. It's the opposite of, not the opposite, but the other view is that don't add more than you need to understand the test. So clean up as much as you can while keeping the test green. And if you have to create a something like you have to prepare, you have to create a user. If it's not relevant, the details of that user for the test, just hide them. If the name is important, make the name obvious in the test. How can you achieve that? Builder pattern is great. If the language support named arguments, use them. That's great. Uh, there are other alternatives, but these are the ones for example, in Go, you can have structs that you create inline. No, sorry, you have structs that you create for the sake of testing. So all of these are ways to make evident what matters and hide what doesn't matter in the test. What was the question?
Yeah, I wanted to add something because this economy of what you use to set up the test and to call the system under test is what makes TDD so valuable because you design the APIs based on exactly what you need and nothing more. And I see this like the number one smell when I look at code and I know that it wasn't TDD'd is when the API takes more data than it needs. And it happens a lot. I sometimes see a lot of this stuff.
Yeah. Yeah, these are just helpers to understand things. So if the test subject doesn't have any dependencies, everything is great. You can use the test subject very easily. You act in a command, you use a query to assert it, or you use some existing query to test some command. Everything is great until while you don't have any dependency. However, when you have dependencies, sometimes depending on the fake, you can still go through the test subject. That's great. For example, you create a profile, you have your code, and that code creates a profile somewhere else. And your fake can save it, just kind of save that it received that profile, so that later your test subject can go to it and give it back to you. And then you're never going underneath under the hood to understand what was done below the scene, under the scene. And yeah, this is the same. The only exception is when you have write only. For example, you have a dependency like sending emails. It's not easy to, your test subject is not going to offer you a function called get emails. So only here you go to the dependency itself to assert. But still, you can write some helper method in your fake to give you like get sent emails, for example. And then with this strategy, you don't rely on mocks. Not relying on mocks is a presentation on its own, so I don't want to go too detailed on that. Another pattern, and I think this is the most powerful one that we are using, is creating an SUT client. So something that sits between the tests and the actual implementation code. This one we are using a lot, and it has a dozen of advantages. This is just an example of using the fundamental theorem of software engineering, creating an abstraction. How it looks is like you have this class that class or file in this case exists only in the in the testing world that sits between you and the tests, and you use it to interact with your implementation. At first glance, the obvious advantages are that you are creating a DSL, creating a language that belongs to the ubiquitous language between you, the users, the business, everyone uses the same language. Tests act as documentation. Tests become, you remove technical verbosity from tests. You have many advantages. You might refactor and keep. Luis already mentioned this. You are helped on refactoring, not see refactor as a burden. And as I told you, this has been used. We have been using this for a while. This was from inventory project, so it's a powerful pattern, and I think it deserves its own presentation. So less verbosity, decoupling to details, friendly to refactoring. I think I covered that. Yeah, you
There's
don't
a
have to
cool thing.
remember. Yeah, yeah. Go ahead.
There's a cool thing that we've been doing with this because um, so I mentioned in the previous presentation that we were working on a V2 or a new API for the cards and keeping the same test. So the tests are the same, and we have like a little table driven conditions like use new API, use old API, and we are able to run the same tests through the same or through this DSL, and we are able to ensure that both the old and the new APIs work the same way without having to write new tests. And this helped us a lot, having this sort of built-in parity checks in our tests. That's it.
No, because there's no coupling to any. You don't even see the calls to the API, and you just in these functions. There's no coupling if it's gRPC or HTTP. That's completely irrelevant. You want to achieve something, you act on as a user would from from these functions, and that's why we can easily swap between A and B in their API wise, like you said. So yeah, I cover these advantages, and this is just a tweet I like. Everything gets easy when you talk the same language as the user. You learn quickly, like newcomers. You embrace the language. You use it everywhere, and using these tests help to spread that know-how. This is how a more complex, a bit of complex test means looks like in this using these patterns. So you have this arrange phase where you prepare something. This one goes to set up something underneath the database. We don't even see it here. Then we set up a discount, we set up manager approval, and then we check the outcome of that. You read like you don't even need to know anything about Go or 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 technical API details of APIs. You could almost read it. Uh, Even if you weren't a developer, you could almost read this. So yeah, I covered this fact that the test subject can have different sizes. People think that unit tests are method tests, but that's not true. That can be the size you just decide for your strategy. This pattern that I just mentioned makes sense only in bigger SUTs, because if it's only a method call, you're not going to create a wrapper around the test subject, right? So it depends. But in our case, since we want to call from outside in and do what the user would do and not anything else, then it makes perfect sense for us. And finally, I don't know what this bell was about. Is it over or what? No, I heard some bell. Finally, don't make me think. This is the most complex one because a lot of things can go in here. I cover these two topics: completeness and conciseness. So don't hide what matters for me, and don't show what's irrelevant. This is the definition of completeness and conciseness. Uh, Also, I saw that in the book. We already use this, but I find it interesting that they are using these concepts. An example is that, for example, in variables, when I read this test, I have to read like 3 times until I understand. My eyes have to look and down a few times just to understand this test. Why not just make everything evident like this? Like, I create a discount calculator. I calculated with these parameters, and this is what I expect. Why do I need variables in the first place? So just make it obvious and don't make me read the same test over and over. My eyes have to just go top to bottom. That's how I love to read a test. But there are many more examples of don't make me think. Don't use logic, like if you're using ifs and fors, something is wrong. Don't magically insert stuff in the database, or there's in Go, there's this thing called setup the suite. I really don't like that pattern because it creates coupling between tests, and the test should be completely autonomous. I mean, you just need to call a function. If you have shared stuff, just call a function. Make every test that wants to call it, just call it. So don't put test data in other files like CSVs and stuff like that. Just make it obvious from the test. If it's a lot of data, create a helper function that receives name parameters, or a builder or something that where you pass only what matters and the rest is randomized. Uh, Shared state, I think I covered these two. Environment variables, this is more on the implementation side, but the tests help to drive it. So don't access environment variables from your code. Only in the environment variables should be only in main and nowhere else. Otherwise, my tests have to set them up. They are like magical things that are read automatically. They are not explicitly injected. So DI is the answer for that. Uh, don't assert more than you need. Don't create like shared by default. Don't create shared asserters, custom assertions, because usually the language has enough. The language or some helper library in the case of Go, but there's always something out there to help you. You don't need to create custom assertions by default. But if you do, make sure they're very tiny. Don't assert a big thing, because then they are not very reusable. And then you have to do ifs inside that custom asserter, that custom matcher. Yeah, the variables
And then you have to write tests for the test
yeah,
functions.
yeah. So make them very tiny if you need them, because I'm very skeptical that you need custom assertions. Like if you assert just one thing that you're asserting, if you follow the first pattern, which is assert just one effect per test, or the second pattern, I don't know, then you might not need, because you are asserting a very specific thing. By the way, the opposite of this is doing snapshot testing, which fails for every reason, and people just accept the new snapshot, never looking at the consequences. So I would be really skeptical that you need snapshot testing. Yeah, so this is the summary of what I've covered. These are the books that I read that inspired me, although we've been using these patterns even before I read them, and they've been working well for us. There are many more patterns that we use, but these are the ones that I try to that I'd like for you to take as a takeaway. Yeah, and that's all. I rushed a little bit. I hope I passed the message. Any questions?
Yeah, Evgeny, go for it.
Yeah, thanks, Luis. All of these very valid points. Of course, we work together, so I went through all of this, and yeah, it works great. Especially, I'm a fan of this testing the system from the outside. It allows you a lot of flexibility. You can change completely underlying, I don't know, technologies, database, whatever, and the system, you don't have to touch the test. It's amazing. The only thing that I have a question, like how do you start, right? Because it's like a chicken egg problem. Like you create a resource, and then in order to assert it, you need to list it, right? But in order to list it, you need to create it, right? How
Yeah,
do you start?
yeah, it's a good point. To be honest, we've been using this on pre-existing systems just to help us move on. Rather than creating a new system, we want to continue with the existing one. So these tests are helpful on that case. I don't start a project from scratch for a while, so I don't have a quick answer for you. I have to think about it before that. But probably you would have to develop the two things like at the same time. I'd guess like probably the TDD would mean you have to develop two functions to be able to assert. I
Or
guess
not. I mean, it can start with
hard coded
um,
stuff, for example.
no. I mean, you have a something that writes to the or something that reads. You start reading something from the system under test, and you check that it's empty because that's the starting state. And then you write a test for something that writes
Yeah,
until the test passes.
yeah.
Eventually, I mean, even the write will fail at the start until there is something in place. Um, so if the write succeeds, if the read succeeds, and if the read returns the right value, then you have the first loop, or the first slice.
Or temporarily use the lower level assertions like asserting database. and then
or not. I mean,
refactor.
it depends. It depends on how you build it.
But it's a good question. I'd have to make some experiments to give you. But yeah, I agree with Luis mostly. Yeah. Who's next?
It's me. Thanks, Luis, for summarizing all the learnings from your experience. I have the question about the SUT client. So the client that we create, is it only used for testing, or is it also? I guess my assumption is that it is also used in the code as well, right? It's not only for
No, no,
the.
no, no. Only for testing.
Oh,
Yeah.
I see.
Because it's a client of the thing you're developing. You're developing some API. You create a client to interact with it. Why would you have that inside your package? It's supposed to describe your software from outside in, and if it belongs to the code, then it's very tempting to use stuff from inside the code, where the goal is to make it agnostic from whatever the code is. So you have to use it from outside in, and it belongs to the test. By the way, we also
An
did
important
end-to-end tests as well, not only in typical tests, but end-to-end. We also created that client.
an important thing is that this needs to be as simple as possible. So no logic inside this client functions or
Yeah.
these DSL definitions. It's what we use it for. For example, is to it's just create a descriptive function that builds an HTTP request and sends it. Basically, sometimes it's just that. Right.
I see.
So it's a wrapper around a fetch or a wrapper around the request. And that way we test the HTTP itself without in the tests, going through the whole thing of building the HTTP requests and so on and so forth. It also gives us some ability to refactor the API because if it's only being called in one place, we just need to change this client function without changing every place where the
Yeah.
endpoint is called.
I don't know if you use the page object model pattern in UIs. Like you have pages that represent the pages, and the pages have like UI the CSS locators, everything, the interactions with the page, and you interact with that object. It's the same, but applied to APIs. So it's just
see.
a generalization of that. But I just sent an article I wrote exactly on that. That gives you more detail on that. because
Thank you.
it's a
I
big
just haven't used it before, so yeah.
yeah.
But yeah,
take a look.
in short, for me, it's like we are reducing the verbosity in the test. We
Yeah.
are using a SUT client, right?
That's one of the outcomes.
Of the codes. I
There
see.
are others like test as documentation is the most powerful one. Like having a DSL that you are constantly using and looking at every day, it teaches you something about the domain very quickly.
I see. Yeah. Thanks a lot.
Is there anyone else in the queue? No, I don't think so. Okay.
Thank you to both of you, Luis.
Thank you.